Okay, so today we're going to learn about hypothesis testing, also known as tests of significance. This allows us to take information that we have about small samples and use it to draw conclusions about entire populations. All right, so it's basically the extension of the central limit theorem. It allows us to use that to do basically what I just said. So the ones that we're going to focus on are the one population proportion, one population mean where sigma is unknown, match pairs, independent samples, and two population proportions. In the squiggly brackets, you can see the sections in the OpenStax textbook that correspond to these topics. In order to understand this stuff, the first road that we have to go down would involve the vocabulary. And you'll notice not very helpfully. Very not very helpfully. Yeah, okay, I'm going with that. It's labeled as 9.1 to 9.5 in the OpenStax text because there really isn't a section, I mean, aside from just a glossary that says, here's all the vocabulary that you need to know all in one shot. It's just kind of sprinkled throughout as needed. Right? I like to get it all out the way in the beginning because it seems to make more sense to have like this one little spot in your notes where you could always refer back to it, like, wait, what does null hypothesis mean again? You know, so that's why I have it the way I have it. All right. So the null hypothesis, assuming that we're trying to draw a conclusion about a population, you're going to have some sort of question related to that population. That question may be, well, is what we're doing the right thing? All right. So if that's the case, then you'd have to identify what we are doing. And then the second layer to that would be identifying whether what we are doing is the right thing. All right. So the null hypothesis we define as the long-standing rule or belief, or really just the policy that is in place currently, the thing that you are trying to either disprove or support. All right. The shortest way of describing that would be status quo. All right. At one point, I looked up the definition of, or not definition, but etymology. Etymology. Oh, etymology definition. That's funny. I should probably look that up too. Status quo. Latin, of course. The state in which. All right. So that doesn't really help, or at least without some sort of explanation as to what that means in in greater detail, it doesn't really mean much. But the commonplace, understood, accepted definition of it is that has always been, that which always is, that which is. For us, mathematically, we use equal signs to demonstrate is. Something is equal to. All right. The alternative would be something other than that. All right. We use the symbol HA instead of H1. Some textbooks, online resources, etc., use H1. I use HA because I think it makes more sense. The A for alternative. This statement is assumed to be true when the null is not. All right. So the only signs that we use are greater than, less than, or not equal. Because if we're going to say something is not equal, we could say that it's simply not equal, but we could also say that it's not equal on the high side, or we could say it's not equal on the low side. Like if I were to ask you to guess my age, and I were to say you have 3 chances to get it right, you could say, okay, you're 50. And I would say no. And then you'd say, okay, I think you're 60. And I would say no, and I would also be getting more insulted. And then you would say, okay, I think you're, and then you'd guess some other number. right? Now compare that to, you're getting warmer, you're getting colder. You know, you're 50. I say no. And then you say you're 48 and I say you're getting warmer. All right. So now I'm giving you a sense of which direction my age is in. All right. So as opposed to just simply saying it's not that age. All right. That's the difference between the not equal symbol and the greater than versus less than symbol. All right. And depending on the question, you may want to find one or more of those possibilities. Generally just a one. But, a follow-up question could ask you, so now that we know that they're not equal, is it more than or is it less than? All right. This is all like hypothetical at this point, as in like hypothesis. So you just kind of sort of have to go with it until we see some examples. But I'm just trying to give an underlying justification for what these terms mean. Significance level alpha, it's the cutoff probability for rejecting a true null hypothesis. All right. I chuckle at that one because I always read that sentence without any expectation that anybody understands what the hell I'm talking about when I say that. All right. And then I follow it up with, it's usually given in the framework of the problem. If not, let alpha equal 0.05. And you're like, oh, of course, indubitably. And then there's words that follow that address all this other stuff related to alpha. But if you don't understand what this first sentence means, then it really doesn't matter what words follow that. It's like, okay, well, now that you understand this, and like, well, I don't understand that. So, like the little follow-up here, in short, the test becomes stronger as alpha approaches 0. Oh, that's wonderful. Oh, we'll have a nice strong test if alpha approaches 0. What's alpha? Significance in a hypothesis test does not always mean that there's a strong effect, only that there's strong evidence of some effect of some imposed treatment. I'm like, oh, okay, what does that mean? Because I still don't know what that highlighted thing means. All right, so again, going back to that, this is the cutoff probability for rejecting a true null hypothesis. So let's just kind of zoom in here. Reject true. Reject something that is true. All right. Is that something we want to do? Nerp. That would be bad. I mean, don't get me wrong. I mean, we've all been in arguments with people where they're wrong and they just, regardless of how much evidence you give them, it's like, no, there's no way. Nope, you're wrong. Like, but it was in the news. Nope. But the guy that you said was missing is standing right behind you. Nope, he's missing. Like, just very stubborn people. There is stuff like that is a possibility, but generally we do not want to reject something that is true. All right, more than generally, we just don't. All right. So it's the cutoff probability for rejecting a true null hypothesis. What that means is that we're allowing for a certain amount of wiggle room in terms of probability. So chances that we're mistakenly rejecting something that's true. All right. We want this probability to be very small. All right. So basically, if I were to say, I could be making a mistake, all right, that's the rejecting something that's true, right? I could be making a mistake, but the chances that I'm doing that are like 0.0001. Then you say, okay, you probably didn't make a mistake, all right? It's akin to saying I'm right 99.999% of the time. It's a lot of logical jargon, but it gets at the idea that I mean, do we want to reject something that we know is true? Do we want to intentionally make a mistake? Of course not. All right. This alpha value helps us avoid that. All right. The power of a hypothesis test. It's kind of weird. The easier to reject a null hypothesis, the more power a test has. To increase the power of a test, we increase alpha, which makes it easier to reject a null. That doesn't really mean much right now until we get an example. Increase sample size. This will decrease alpha. Okay. I'm sorry, sigma. Same idea. So I'm going to say hold that thought on power. All right. Because if we were sitting in a classroom right now, the hands would be going up. Be like, I don't know what any of that means. Can you re-explain it? It's like there's nothing to re-explain yet until we see it in an example, and then we talk about it a little bit more. Type 1 and type 2 errors. Type 1 is rejecting a true null. Right? We reject something that's true, not a good thing, so an error. Accept a false null, not a good thing, so an error. The one that's the worst of the two is the type 1, because the null hypothesis is the long-standing rule or belief. If you reject a long-standing rule or belief, basically something that society might be built on, you better have good reason for it. If you accept something that is a long-standing rule or belief incorrectly, the worst thing that happens is that you just keep doing what you're doing, even though it's not the correct thing. And even that could be horrible, but you're not making a change for the sake of making a change. All right. So mathematically, it's considered to be worse to reject the true null. And also alpha, the thing that we're still laboring to understand, can also be thought of as the probability of making a type 1 error. All right, so the terms throughout the course are still kind of coming back, like probability is being used over and over again. And in a little bit, we'll talk about how we incorporate means and standard deviations a little bit more. We have two different ways to conduct a hypothesis test. We have the p-value approach. When computing the p-value, and we'll use the graphing calculator for that, so that's good news. Justifies the purchase. If it is less than alpha, if the p-value that we come up with is less than alpha, the probability you're mistakenly rejecting the null hypothesis is negligible. Therefore, it's proper to reject a null. Again, in an example, it'll make more sense. The p-value is the probability that the null hypothesis is true. All right. So, I mean, it's really not, but it's a nice way of kind of like intellectualizing it. Alpha is a cutoff. P-value is less than the alpha, then the probability of H sub O, the null, being unacceptably small, or true, is unacceptably small, so we reject it. That's not precisely an accurate definition, but a lot of people just go with that as a working definition. So that's what I'll say here. It's a working definition, and I'll take that as a typo. Okay, and so we're going to just kind of carry out our first hypothesis test, right? But I want to end this video here because this is where we're, kind of just finishing talking about the terminology, and then we'll get into a case by case. I'll make one video for each individual case, and then we'll go from there. All right, so that's where I'm going to cap it off on page 62. And there it is.